Hey Rob, how are you?
Hey Debbie, did you speak to me? I had my earphones in.
I did. I said, how are you?
I'm doing well. You're sounding good, so that means we can hear you very well. I'm hoping we have a good class.
Yeah, we will. I can hear you all good too and see you,
All right,
so
all right, good.
it's okay.
Thank you.
So the first thing you have homework 2 for me. Rob, I guess you're getting those. You folks here, make sure we got a name on them, please. If you're emailing them to me, hell, that works too. I'm good with whatever. Thank you, sir. Where we left off last Thursday, we were talking about normal distributions, standard normal, z-score. Look, I want to start maybe like 5 minutes into last week to remind you where we were at, okay? And here's what I was thinking is, I think the example we were using, I was looking at the Iowa test scores of 7th grade students in Gary, Indiana, or something like that. And it turns out they had a normal distribution with a mean of something, 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 with a mean of 6.84 and a standard deviation of 1.55. At some point we were looking at that, right? And remember, that's my notation, because I'm going to use this notation on you again tonight. Remember, right there, 6 my mean, and that's my standard deviation. The mean's your locator, and the standard deviation is doing this, right? And I had asked you like a question, which one of the things when we got started on the standard normal last week was, what percent of scores are less than, and I think the number I picked was 6, and then I wrote in symbols, you know, I want to use capital P for percentage, proportion, area under a density curve, and I always use X for whatever the variable here is here, and then, you know, it's a test score, and I want the percent where X is less than 6. Now, I picked a reason 6 because 6 is not 1, 2, or 3 standard deviations away, right? So that whole 68, 95, 99.7 rule didn't work. Yes? So, we come up with this, I'm going to leave this here for a second. We came up with this idea of something called the standard normal distribution. Right? So, bless you, it's normal, its mean is 0, its standard deviation is 1. So it's the normal distribution centered at 1 and has this standard deviation of 1. And what we want to do is we want to measure everything, whatever normal distribution is given to us in the problem, we want to measure everything in terms of the number of standard deviations away in observation, z-score. So when I think of standard normal, I think of standardized values, and I think of this guy right here. Right? And so standardizing your value, calculating the z-score, takes us from whatever normal distribution me and you are working with into the standard normal distribution. And here's my thought. All right? So I'm going to go back to where I started here today. That normal distribution looks like this. Right? I'm going to label for you 6.84, 1.55. We know the mean is sitting right here in the middle. You remember that percent question I was interested in? What percent of the scores was less than 6? So remember, when your original normal distribution is given to you, what lives on the x-axis are values of your variable. In other words, it's Iowa test scores here. And so 6, I'm not exact, but I do know it's to the left of 6.84. Well, I would like to know this area. Because remember, the area represents a proportion, and a proportion will give me a percentage. So when I think about this, I'm interested in the percentage where the scores are less than 6. The reason I'm drawing it for you like that, that area represents the answer to that question. Are we okay with that? So, my problem is I don't have any way to calculate this. I don't even have any way to look that area up under that particular normal distribution. So what we have to do is, we have to standardize and go to the standard normal distribution. When I say standardize, I mean calculate a z-score. It's always an x, a value of the variable, minus your mean, and divided by your standard deviation. Anybody got a calculator, please, today? Right, so I'm going to take 6 minus 6.84, divide by 1.55, and I'm definitely expecting a negative number here. I know I'm expecting a negative number because 6 is smaller than 6.84, right here to the left. What'd you get? Yeah, so I got a negative 0.54. Everybody agree? Remember, I always give you 2 decimal places on your z-score. I have a reason for that. And so what happens is, just like the z-score takes our normal distribution into the standard normal, I'm not going to draw it right under it. What happens is, this takes me to this normal distribution. You'll notice the standard normal, because I'm going to label it normal, mean 0, standard deviation 1, that's the standard normal. The mean is 0. And what lives on the, I can't say x-axis, what lives on the horizontal axis under the standard normal is z-scores, standardized value. So I have, remember that got calculated from 6 in the original one. I want this area right here. Because that area under the standard normal to the left of the z-score negative 0.54 is exactly the same as the area under that normal distribution to the left of 6. That area is equal to that area. Every time. Now, just for the sake of things, the book, I'm on page 87. I'm going to throw this term out there, and then I don't usually say anything else about this term. But there's something called a cumulative proportion. All that means is, it's the area to the left of some value. See this guy right here? In the book's language, we're looking up a cumulative proportion, right? Or a cumulative area. It's the area to the left of some value, yes? You see that area there? That's a cumulative proportion, right? It's the area to the left. And why do I care about that? Because the table me and you are going to use to look up that area gives you these cumulative proportions. Look, just make it real simple. It gives you the area to the left of your z-score. That's the point. Okay? So, in your tables and formulas you printed out, I've got one here I'm going to show you and pull up. It's very similar to the ones you guys got. There's this table A. We go nowhere in this class now without table 8. Okay? So I'm going to see if I can pull this one up for us. I've got it. So these are your 6 pages and tables and formulas that you guys have. And so there's my table 8. Right? Here's my thought about table 8. You'll notice on the left-hand side is like you see like negative 3.4, negative 3.3. In other words, that's the 1 position of your z-score and the 10th position, right? There's negative on the top, there's positive on the bottom. You see across the top of the table where it says 0.00, 0.01, 0.02. They're all squinting at me here. It was all right. Hell, I was standing right over it. My ass was squinting, so yeah, we're good. So down the left-hand side are these negative 3.2 and so on, right? So that's the 1's position and the 10th position. And across the top is giving you the 100th position. And remember, every time you calculate a z-score, you're giving me 2 decimal places. So, okay? Now, the way we use this table is, remember, this table always gives me the cumulative proportion. Translation, it gives you the area to the left of whatever you look up. So, when I come back here, I wrote down table A, and for a while here I'm going to do this to you. What row do I need to look in? The row I need to look in is negative 0.5. Notice the 1's position and the 10th position. And the column I need to look in Does everybody understand? When I put that together, that row and that column, that's actually a z-score of negative 0.54. So what does that mean? That means when I come over here to this table, I go to the negative 0.5 row, and then I got to figure out which one it is. It's the fifth row across, right? So I'm going to keep my little cursor right there on the fifth one. And then when I come down here, you see this number? I'm in the negative 0.5 row, the 0.04 column, and I believe, and somebody stop me if I'm wrong, I'm reading 0.2946. Is that correct? 0.2946. Everybody understand that, right? Negative 0.5 row, 0.04 column, gives me a proportion of 0.2946. So I come back here, and I remind myself, okay, what did I find? One more time, the table always gives me the cumulative. Can I stop saying that and just tell you, it's giving me the area to the left? Yep. So, what did I just look up? I looked up that value right there. That's what that table gives me. It gives me the area to the left of that z-score. Well, if that area there is 0.2946, I always got to back up a page for you, because that means this area here, they're the same. That's the reason for me and you going from the one that's given to me in the problem to the standard normal. I have a table for the standard normal. Everybody okay so far? That's the exact area. Now, you remember my original question? I'm going to write the original question. I got it right there, but I'm going to write it over again. The original question was, what percentage of the test scores were less than 6? You see my answer here is 0.2946. That's the amount of area out of 1. That's the proportion out of 1. The question asked me for a percentage. How are we going to change it? I'm moving the decimal place 2 to the right. If you guys don't like that, multiply by 100. Right? And so I'm going to get 29.46%. So the percentage of test scores less than 6 is 29.46%. Yes, I'm going to go very slow here today. Remember, this kind of stuff shows up in this chapter, it shows up when we talk about probability, and it shows up at the end of the semester when we're doing calculations. So this is kind of an important deal. Are we okay with that one? And then I kind of like pulled that one out of thin air anyway, right? Because I was talking about the Iowa test scores. Okay? Now, can we come to some agreement about the table for a second? And here's my thing. I'm going to show it to you again. And it doesn't matter if you've got the one there, the one I've given you, or what. They're all the same. Okay? The only difference is if you look at the one in the book, and it's in the back of the book, it's on 2 pages. The one here is all on 1 page. This is still the same table. Now you notice, I'm going to scroll up here. What's the smallest z-score I can find? The smallest row is minus 3.4, right? So the smallest z-score I can find is minus 3.49, yes? So here's what we're going to say. If you have a problem and you get a z-score that's less than minus 3.49, in other words, it doesn't fit on the table, right? The smallest you can go is minus 3.49. We have to come to some agreement, and our agreement is area to the left. Anybody know my little symbol approximately? That's my approximately symbol. We're going to say it's approximately 0. Is it exactly 0? No. But it's approximately 0. And then that means the area to the right is what? What's the total area under the curve? 1. If you have almost 0 area to the left, how much area is to your right? Almost 1. Approximately 1. And you're going, will you ever see a problem where the z-score is less than that? Oh, it's definitely a possibility with me. Now, what's the largest z-score we can look up? Well, you've got a 3.4 row, 0.09 column. The largest one you can look up is so what do we do? Okay, you give me I get a z-score of 4.72. What do? Am I done? No. Here, the area to the left of whatever it is bigger than that, approximately 1, which means the area to the right is approximately 0. So I mentioned that once, and then maybe when we mess with some of these where we get crazy outside of there, I'll remind you this little story. But that's how we handle. So at this point, me and you can handle any z-score we want. If we're smaller than this, or bigger than this, or we can actually use the table. Then I got one more question for you, and then we're going to work problems. You see this statement right here? That x was less than 6, right? In other words, I wanted the percent of the scores that were less than 6. Would I have changed anything if I had 6 or less? In other words, throwing in, me going less than or equal to, I'm throwing in the 6. Throwing in that 6, does that change the area under the curve? I would work the exact same way. Right? Whether I include 6 or whether I don't include 6, it's exactly the same. Okay? Now, like I said, we need to work a few problems here, different ones. I'm thinking I'd like to come over here and look. Your book's got this page 89, using table A to find normal proportions. I'm going to work every problem exactly the same here. At least the first 3 styles that I have. They're all exactly the same, and I do the exact same steps. All right? And so what I was thinking is, maybe we should try 311. And I'm on page 90. Just to show you, okay, how do I get the information out of the problem? How do I know what to do? So problem 311 says this. The summer monsoon rains in India follow approximately a normal distribution. This is what I warned you last Thursday. As soon as I was reading that, I wrote big capital N. Now, what am I looking for? What am I looking for in the rest of the problem? I'm looking for a mean, and I'm looking for a standard deviation, right? It says, with a mean of 852 millimeters, and then a standard deviation of 82. Just to remind you, there's your mean. So they're telling me I have this normal density curve. They're telling me where it's centered, and they're telling me about a standard deviation. Did anybody ask a question yet? That's all in the setup. It says, in the drought year, 1987, 697 millimeters of rain fell. And what percent of all years will India have 697 millimeters or less of monsoon rain? So, I'm going to give you, this is part A. I want a percentage. I'm going to use X for the yearly monsoon rain total. What do I want? I want the monsoon rain total to be less than the drought year of 697. And it's actually 697 or less. Now here's the deal. I know in this problem I'm talking about monsoon rains and all of that crap. I don't care. You see less than or equal to? To me, it looks exactly like this problem. Oh, it's a different normal distribution, different mean and standard deviation, but... Now, here's the thing. I'm a picture drawer. I'm very visual here. So, what do I have here? Here's these monsoon rains. They follow a normal distribution. The mean is 852. What value of the variable am I interested in? I want the percent less than or equal to. Folks, I want this area here. The statement I have here, that's telling you which way to shade. It's telling you to shade less than. I don't even mess with, are you 1, 2, or 3 away? I don't even think about the 68, 95, 99.7 rule unless somebody points it out to me. Because normally, you're not 1, 2, or 3 away. So what do? We have to standardize. It means I need to use this formula here. Yeah, I wrote it out for you. What's my x? What's the value I'm trying to standardize? 697. What's my mean? 852. What's my standard deviation here? I was thinking it was 82. So I'm getting a negative something something here. 1.89. Cool. So just to review a second, that's telling you that z-score is telling you that 697 is 1.89 standard deviations to the left or smaller than the mean. Just reminding you what the z-score is telling you. So as soon as you see me do that, then I come over here. I'm going to draw you the standard normal. I'm going to put that z-score on there at negative 1.89. And I know whichever way I wanted the area last time, I wanted exactly the same. Now, students always want to know, do I got to draw the pictures for you? Nope. You just got to get the answer right for me. Can you do the calculation and not draw the pictures? Yeah. If you know the sequence of what's going on here, fine. So, this has got to be table A. Just to remind, what row am I going to be in what column? Row is negative 1.8, and the column is 0.09, right? That will put me together to give me my minus 1.89. So, I'm running to find table A. I'm going to find the negative 1.8 row. So, I'm in the negative 1.8 row, and I want 0.09. I'm reading, what is this? 0.0294. Yeah. Oh no, I trust you guys better than I trust myself, right? I'm in the minus 1.8 row, 0.09 column, so I'm getting a negative, a 0.0294. That means this is, if that's 0.0294, what we just looked up was this. Remember the area to the left? If that's 0.0294, that's 0.0294. And then I always stop. Did the problem ask me for the percent or did it ask me for the proportion? Here it asks you for the percent. Move the decimal place 2 to the right. And I'm going to get 2.94%. Right? So in 2.94% of all the years, we'll have an average annual monsoon rainfall of less than or equal to 697. That's one type of problem. And what I mean is, we gave you a value of the variable, and we asked you for the area, proportion, or percentage to the left. There's two more types. I want to look at, I can't do part B yet, sorry. Okay? I'd like to look at 312, part A. But again, they're going to change the variable in what we're looking at. 312 says the medical college admissions test, MCAT. Almost all medical schools in the United States require students to take the MCAT. A new version of the exam was introduced in spring 2015 and is intended to shift the focus from what applicants know to how well they can use what they know. All right. One result of the changes on the scale is the scale on which the exam is graded has been modified. Yeah, no shit. With the total score of the 4 sections on the test ranging from 472 to 528, in the spring 2015, the mean score was 500 with a standard deviation of 10.6. And every semester, since I got the new book, I always read that. Did anybody hear me say the word normal? Very bothersome me. But we're going to make it normal. I ain't going to do the problem unless it's normal, right? So it's normal, and the mean here is 500, and the standard deviation is 10.6. So there's your third one, right? One was Iowa test scores, the next was monsoon range. Now I'm looking at MCAT scores. Yep. And so part A says, notice it's what proportion. Okay, so we just won't move the decimal place. Students taking the MCAT had a score over 510. The proportion now, big capital P, percentage, proportion, area. X is my variable. What does it mean over 510? Greater than 510, right? Over 510 means greater than 510. So again, me, being visual, here's this normal distribution. Right, the mean sitting right here. 510 this time turns out to be on that side. And I don't care where it is, right? Just put it in relationship to the mean. And then I always draw this line. And then I got to ask you a dumb question. Which way do you want to shade? Do you want to shade to the left of that line or to the right? Remember, that tells you which way to shade. Are we okay? Now, what's the next step? It's got to be a z-score, right? You got to standardize. When I standardize, the value of my variable, x, minus your mean, divided by your standard deviation, right? And everything's sitting here looking at me. 510 is my x. The mean is 500, and the standard deviation is 10.6. This time, my z-score is actually going to end up being positive 0.94. Just to remind you, that means that 510 is 0.94 of a standard deviation greater than the mean, not one full. Positive tells you to the right. So, where did that take me? To the standard normal. Centered at 0. 0.94. I'm really just writing everything over in terms of the standard normal now. I'm shading the same direction and everything. Now, we still need table A, right? Even though I'm looking to the right, because table A, I'm going to look at what row? 0.9. The column is going to be 0.04. So, I come over here, 0.9 row, 0.04 column. I'm thinking I'm looking at 0.8264. Anybody agree? Well, you got to agree with me up front, because if I screw it up, then I'm screwed up all the way down the page, right? So I'm thinking 0.8264. So now here's the thing. What's the table always tell me? Cumulative. It always tells me to the left. I know I want to the right, but it only tells me to the left. So what it just told me is, this area here that's not shaded is, well, how am I going to find what I want? What's the total area under the density curve? Oh, I kept screaming like a madman last Thursday about that. I asked that dumb question like every question, right? So what am I going to do? To find this, I'm going to take 1 minus. Then I'm going to ask you, does it make sense? If the total amount's 1, this amount here is 0.8264. If I take 1 minus that, that's the part that's left over in red that I want. Well, what do I get here? I get .1736. Correct? So if that area there is 0.1736, that one there is 0.1736. And then, do I need to move the decimal place, or can I just take it? It says, what's the proportion? The proportion is 1.1736. Or if you like, if it asks you for the percentage, it's 17.36%. So now that's a little different problem, right? Remember, 1, they give you a value you find to the left. 2, they give you a value you find to the... Now, there's a third, but we got to find one more of these. And for me to find one more of these, I have to come over to your homework problem. And we got to go to, I'm on page, I got to find another one like this style. And what I mean, what makes it like this style, we gave you a value and you look to the right. So I'm going to come to page 96. Look, I want to work a problem every style I can think of so you have something to go off of. So if I look at 3.35 here, and it turns out 3.35 is a chunk of all this, and so this, at the bottom of page 96 on the left-hand column, there's this miles per gallon, and it says, in its fuel economy guide for 2016 model vehicles, the EPA gives data on 1,170 vehicles. There are a number of high outliers, mainly hybrid gas and electric vehicles. If we ignore the vehicles identified as outliers, however, the combined city and highway gas mileage of the other 1,146 vehicles is approximately normal. Thank you. I better be given a mean. The mean is 23. And the standard deviation here is 4.9. So there's our fourth normal distribution. Notice the mean always changes, the standard deviation always changes. See, it would be nice if I didn't have to standardize, if I had a table for every possible mean and standard deviation we'd ever see. It would tell me the area to the left of whatever the value is. You understand we don't have enough paper. Right? That's the reason we're going to the standard normal. I need one piece of it. Okay? The problem says, I love my boat. The 2016 Volkswagen Beetle with a 4-cylinder 1.8-liter engine and automatic transmission has combined gas mileage of 28 miles per gallon. Very nice. What percent of all 2016 vehicles have better gas mileage than the Beetle? What did it ask? Percentage? P. You understand that P is going to stay with me and you the rest of the semester. Percentage, portion, area. What are we using for X? That's the combined highway, city and highway miles. Right? Whatever the variable is, it's always X to me. What does it mean to have better gas mileage than the Beetle? Better than means greater than the 28. The reason we're doing this one is hopefully it looks exactly like that one to you. Okay? So, I draw you the normal distribution. Look, if you're following perfectly and I'm boring you, just stay bored. Alright? Make sure you understand where I'm pulling all my numbers from. I want the area to the right. Yeah. Now, at this point, it's always the same story. It's, let's calculate a z-score, take the value of the variable we are interested in, 28, subtract off your mean, and divide by your standard deviation of 4.9. I should get 1.02. So that means 28 is 1.02 standard deviations to the right or greater than the mean. The plus sign's telling me that. Again, if you don't like drawing the pictures, don't. All I ask of you is you get the right answer. 1.02. So where am I going? I'm going to table A. I'm going to the row 1.0, column 0.02. So I find my table. I go to the 1.0 row, and make sure you're looking in the right spot. It's not the 0.1 row, it's the 1.0 row, 0.02. I see 0.8461. If anybody else sees anything different, let me know. Now remember, with these types of problems where you're looking to the right, there's an extra step here at this point because it's telling me this is 0.8461. So what do we got to do? We want it to the right. Subtract. How am I going? Look, I'm old and I ain't got a calculator, so the area to the right is 0.1. Look, if you get that part right there, hell, that's your answer. I just always come back and remind you, well, you know, you really wanted to know this over here. 0.1539. And then I know at this point, if you can get that, the question's only going to ask you for the proportion or percentage. Depending on what it is, you'll give me the answer, right? Especially on a multiple choice test. I mean, if all the answers are in percentages, you'll move the decimal place to the right. If they're all in proportions, you'll just leave the shit alone and give me that answer, right? So here it says percent. And I guess we should come to this agreement. Is that the same thing as? I rounded up, right? All those are good. You pick the one that's closest to what you got. Now, two types of problems. Value to the left. Value to the right. What's left? Two values. So, I have to back up here. And we can go back to the monsoon range. Right? So I want to go back there. Monsoon range in India is 311, and I want to do part B. Now, it's the exact same normal distribution where we did 311A. They follow a normal distribution. They have a mean of 852 and a standard deviation of 82. All that stays the same. What the question is asking for is what's going to change here. It says this: normal rainfall means within 20% of the long-term averages, or between 682 millimeters and 1,022 millimeters. In what percent of all years is the rainfall considered to be normal? So you notice there's not just one value this time, there's actually percent. What's my two values? I want between those two, it's 682 and 1022. And students always want to know, well, is it greater than or equal to 682 and less than or equal? I don't care, because it doesn't change how I'm going to do the problem, right? I know 682 and 1022. Now, this might be where you might have to draw a few pictures for yourself. What does this look like? Here's your normal distribution. Folks, am I going too fast? Johnson City, am I going too fast? Are we good? You can talk to me as you. Well, you got to remember, I know what the hell's going on, so I'm rambling, keep on rambling. I want to make sure you understand where my stuff's coming from. You'll notice when I read the problems, I read everything. And when I read the problems in this chapter, I'm looking for normal, mean, standard deviation, and we'll figure out what the question is. All right? So it turns out this time, you've got 682, and I've got, there's two of them. So I always draw a line down. I've been doing that all along. And then there's actually three places to shade here. To the left, between, or to the right. Well, yeah, I want between. Because remember, my x is between 682 and 1022. Now here's the catch. There's not one value of the variable to standardize. There is two. So there's going to be two z-scores. Let's do 682. I'm going to take 682 minus 852, your mean. I'm going to divide by your standard deviation. I'm going to get a negative something something here. I'm hoping it's a negative 1 point something.
Negative 2.07.
Oh, I'll make that shit. That's even better. 2.07?
Yeah.
Negative, right? Because we're to the left. Okay. Nice thing is it still fits the table. And then over here, I'm going to get a different z-score for this 1022. Subtract off your mean. Divide by your standard deviation. Folks, I read it like that every time. Even though I'm not telling you the numbers, it's always the value of the variable minus the mean divided by the standard deviation. This time I should be getting something positive. And for some reason, I was thinking I might get good. So there's two. So where does this take us when we standardize? It takes me over here. standard normal. Mean sitting right in the middle. I got one negative z-score. I got one positive z-score. And whatever I shaded on the other page, it's the same. Now here's the thing. I can't look up the area on the table between two. I can only look up the area to the left all the time, correct? So you're going to have to look up two z-scores. You're going to have to go to table A, and you're going to have to look up. The first one is row minus 2.0, column 0.07. And the second one is row 2.0, column 0.07. So there's got to be two looked up. Now remember, it's only going to tell you to the left. So the negative 2.07 is going to give me negative 2.07. That one looks like 0.0192, right? So this one here is giving me. Now I got to go back to the table. I got to go to the 2.07. So the 2.0 row, 0.07 looks like 0.9808. Yep. This one here is giving me 0.9808. Now, my next move is this. I'm going to give you a way to find that in the area, that red. I'm not saying it's the only way, I'm saying it's a way. Here's the thing. What we know is this, is that from here down, that area is 0.0192. Everybody agree with me? I know I didn't shade the area, but from that point down, the area under the curve is 0.0192. And from here down is 0.9808. How do I get what I want? You see, I got to do a subtraction problem, right? I got to subtract the 1 from minus 2.07 from the 1 of 2.07. In other words, to find this, what I want in red, where I'm going between, I need to take 0.9808 and I need to subtract 0.0192. She wanted to say it. She didn't say it. The area between is 0.9616. That means this back here that means, did we want a proportion? Did we want a percentage? It asked me for the percent. I gave you the percent. How are we? So the way I see it is there's three problems. A value to the left, a value to the right, two values in between. Right? That's your third type of problem. Do I do everything the same all the time? Well, I have to keep in my mind that the table only tells me to the left all the time, so sometimes we've got to be a little creative. And this move right here, that's a little creative. To subtract that one from that one to get what you want to do. What I was thinking was this. We need to do one more of these, so then I've done 2, 2, and 2. Right? Again, so you got something to look at when you get away from me. Because as long as I'm sitting here talking and you're writing what I'm saying, this shit makes perfect sense. The problem is when you go to the house and I'm not sitting there talking with you, and you got to figure out what to do. So I want to do one more of these. And I was thinking about part B on the MCAT test. Right? So 312, part B. Remember, those MCAT scores are normal with a mean of 500 and a standard deviation of 10.6. So part B says, what proportion, capital P, had scores between 505 and 515. All right, so it's a proportion question. I don't care about that. We fix that at the end. I want the proportion between 505 score and 515 score. So again, I got to draw the pictures just so that everybody's on the same page. If you don't need them, I'm good. So I like to label things. Notice this time they're both on this side. Okay. I don't care. Just put them in where they need to be. They don't have to be exact. And I want the weird thing is this stuff right here is about the first time you needed me all semester. But this is the point where it actually feels like math class. I mean, I've been calculating my ass off all day here, right? Z-score, reading the table, giving back numbers. I'm not interpreting. I'm not making graphs. I'm not doing any of that stuff we did. We're very mathematical at this point. Now, we need two z-scores. I need a z-score for the 505. 505 minus your mean divided by your standard deviation. It's not very big, is it?
0.47.
What was it?
0.47.
Negative. Agreed? Oh no, it's positive. I take that back, man. 0.47. And then I need to standardize the 15. 515 minus 500. Well, at least I got one something here, don't I?
1.41.
Now again, I wish there was some magic here. I could just tell you, okay, the answer is 0.2346, but I can't. I got to use table A. I got to go to the standard normal. I got to draw myself the picture. I wish I didn't have to, but I do. I got one z-score is 0.47. The other one was 1.47. That's 41. You just told me what it was. That's all it was. So again, I'm going to write everything out for you so that when you get away from me, you know at this point I went to table A. I'm in the row 0.4, column 0.07, and for the other one, you're going to be in the row 1.4, column 0.01. All right, so then I'm running to the table, trying to make sure I don't mess things up. So I'm in the 0.4 row, 0.07. It looks to me like I'm getting 0.6808, right? If I'm in the right column here, and that's the column there, 7. 0.047, so it's that row and that column. It looks like that's 0.6808. That's this guy. And then if I go to the 1.4 row and the 0.01 column, remember the first column is always 0.00, so I'm looking at 0.9207. And then, I know you hopefully understand we're going to subtract, but I always come up and say, okay, I'm going from here to here. That is your 0.6808. That one there is from there to there. That's your 0.9207. I feel like when we look at it like that, then why I'm subtracting and doing what I'm doing makes a little bit of sense. And then do the subtraction. Right? So we're going to take 0.9207 minus 0.6808. Now, one thing I want to say about these ones where I'm subtracting, I'm not subtracting z-scores, right? I'm actually finding the area and subtracting the areas that we found in the table. So if that's 0.2399, that is 0.2399. And the problem asks you for proportion, so don't bother multiplying by 100 or moving the decimal place. That's your guy. Three types of problems so far. A value to the left, a value to the right, two values between. Well, there's a fourth type. The fourth type is a little more interesting. If you feel comfortable with this, the fourth type is a little more interesting. And what I mean by more interesting is, I'm going to say it one more time. The three types we did: a value of the variable, the area to the left. I say area. It could have been percentage or proportion. A value of the variable, the area to the right. Two values of the variable and the area between. Everybody understand that, right? That's what we've done so far. So now, we want to think about finding a value of the variable given a proportion. And if you don't mind, I'm just going to put a little slice or a percentage. Because I'm going to give you like a couple different little styles here. So the way I think about this, understand, that's completely different. Right here, you're going to be given a proportion percentage up front, and what you need to produce is a value of the variable, right? So I want to think about this because of the language I've been using on you. We want to work backwards. In other words, you know how I draw that picture, calculate the z-score, draw the next picture, produce your answer? Well, I'm just going to work from the bottom of the page up. Okay? So here's my thing. I don't want to do this example 3.9 because it's using software. I want to hang off on 3.14 for a second. I want to come over here, and I would like to look at problem 3.36. It's still the EPA and all that stuff, the miles per gallon. So I'm on page 96, and I want to look at 3.36. So remember, all that stuff about the bug, the beetle, remember we had normal distribution, the combined highway and city miles. We had a mean of 23 and a standard deviation of 4.9. That doesn't change. I still need a normal distribution, I need its mean, and I need a standard deviation. So the thing that's different is, it says, the top 15%. How high must a 2016 vehicle's gas mileage be to fall in the top 15%? So here's my question. Did they give me a value of the variable, or did they give me a percentage or a proportion? Top 15%. This is going to be a work backwards. Find x. All the other problems was giving me x. And I'm going to put it like this. Find x for top 15%. And I apologize for you folks that aren't like math people. And some of us aren't here. You know, everybody takes 15, 30. That was me being me, I need to find x, right? In other words, I need to find a value of the variable. When I'm done, I'm going to have a value of the variable here, right? That's the point. Find x. Okay? So we're going to work backwards. I'm going to read the table from inside out because we've been reading table A from outside in, right? Give me a row, give me a column, find that. We're going to read from inside out. So working backwards means I'm going to start with the standard normal. This guy right here. Remember, I labeled for you. Here's my question. There's got to be a value, there's got to be a z-score that has 15% of the area greater than that. Why am I interested in greater than? Top 15%, right? So, if you're looking at 15%, what's that in terms of a proportion? In other words, move the decimal place to the left to take it from percentage to proportion, divide by 100, however you want to do it. Now, let me ask you this. This z-score that's going to be under here, right? And I know it's a z-score, as z-scores live on the horizontal axis of the standard normal. Is it to the right of the mean or is it to the left of the mean? In other words, are we expecting a positive z-score or a negative z-score? I'm kind of hoping we're going to be a positive one, right? Because we're in the top 15%. Remember, the mean has 50-50. Well, hell, you're looking at 15%. It's got to be greater than the mean. So there's some value here And what I mean value here, I'm going to label it. I don't normally do that with the other problems. There's a z-score that this area right here, you agree? Because remember, the total area of the curve is 1. There's some z-score here that 15% of the area, or 0.1500 of the area, is to its right. Hey, what's the table always tell me? I made a big deal at to start with. When we use a technical term, it gives you the cumulative proportion, right? What does that mean? It only tells you the area to the left, correct? So if there's 15% of the area to the right, how much is to the left? Subtract from 1. That means over here is, you agree? Those two numbers has got to add to 1, 0.8500, 0.1500. Now, I wish I knew off the top of my head what the hell that z-score is, but sorry, it don't work like that with me. So, I'm coming to the table. Do we expect the z-score to be positive or negative? We expect it to be positive, right? So, I'm only going to be in this chunk of the table. The positive parts, right? I don't need this part up here. Remember, I'm looking up 0.8500. I'm reading the body of the table. I'm reading inside the table. You're not going to find 0.8500 exact. You're going to find the values that is closest to it. Well, I'm looking here, and I'm in the 1.0 row, because that's where we start with 0.8413, and we end up at 0.8621. So I'm somewhere in between there, right? The one that's closest is 0.8508. Everybody see that right in the middle of the table? Yeah? I don't care if it's bigger or smaller. I just want it to be the closest. And the closest thing I find to 0.8500 is 0.8508. I'm going to come over here and tell you what I just found in table A. I found 0.8508. Well, I'm going to give you, obviously, we're reading the table inside out. You need to know what row this is in and what column it's in. Well, again, I didn't really pay that much attention. It's in the 1.0 row. And what column is it in? 4. Yeah. 1.04. So it's the 1.0 row and the 0.04 column. I want to say that again to you. I want to look at it again, all right? I need 0.8500. I find right here, 0.8508. I'm in the 1.0 row, 0.04 column. So the z-score, putting that together, it's not like I'm adding or anything like that. I'm taking the ones and the tens and I'm putting in the hundreds position. That's going to give me a z-score of 1.04. So look, what this is telling me is this. The z-score that has the area 85% to its left and 15% to its right, that's your guy, right? Is it exact? No. Is it close? Yeah. So what I need is, I need the value of the variable that's 1.04 standard deviations greater than the mean. So don't freak out here, because here's the deal. If we got this part, remember my little z-score formula? Let's plug in what we know. I know z is 1.04. I'm looking for an x. I know my mean here is 23. And my standard deviation is, I'm thinking it was 4.9. You understand, right? I'm supposed to produce a value of x. So don't be shocked when I plug in here that there's an x missing, right? We want to solve for x. So, I don't know how your algebra skills are, but that's what you want to do. In other words, what I would like to do is multiply both sides by 4.9. That just means do not throw away anything. Put some parentheses so you don't mess up with your calculator. Right? So, if you want to think about it, I cross-multiplied, or I multiplied both sides by 4.9, and then I need to add 23, right, to get the x by itself. So I'm going to get 1.04 times 4.9 plus your 23. And then we definitely need a calculator here. And I'm going to write it. You're going to produce me a value of the variable x. Right? X, get it?
28.096.
You're saying it like I shouldn't believe you.
Well,
No. I mean, it's a little bit bigger than 28, I'm going to say. It should be around 28. There you go. You got 28.096, right? So I'm going to write exactly what the calculator was giving us. So that's like 28.1, right? I mean, we are talking miles per gallon. Do I really want to talk about 28.096? Okay, so I'll leave it exact. Now here's the question. It says, how high must the 2,000 vehicles gas mileage be to be in the top 15%? Well, we know a miles per gallon of 28.096 has 15% of the area to the right, yes? So the way I would say it is, I mean, we can be different than that. We can be 28.096 miles per gallon. Yeah, it's a variable, right? Put back in units. Or if you're higher than that, won't you be in the top 15%? Yeah, because the 28.096 is here, and anything from there out is going to be in the top 15%. Is there anything special about the top 15%? Could we have done the top 10%? We'd have looked up 0.9000 in the table, right? Could I have done the bottom 15%? We like bottoms better because bottoms, I look up the numbers given to me. My problem here was we were in the top 15%, so we didn't look up the 15%, did we? We looked up the 0.8500 that was left over. Now, that's a working backwards. There's one other style of working backwards we need to talk about. See, because to me, the way that problem's worded, give me the value of x to put you in the top 15%, or the bottom 15, or the bottom 10, or the top whatever, right? We need to back up here and do one more out of one of these. I want to do this one, and I want to look on page 93, right, 3.14. One of them I want to joke with you about, and the other two we should actually calculate. Because they don't explicitly say, the top 15% or the bottom 10% or whatever, but on page 93, before we do that, you see all this stuff here? Where I'm telling you to solve for x and all that. It might be easier for some of us. What did I actually get if I take all the numbers away? Isn't that what it is? You might want to write that shit down somewhere. Because that's exactly how I got there. The z was 1.04, the standard deviation was 4.9, so it's actually z times sigma, and then what's the plus 23? The plus 23, that's plus your mu, right? You know what I did, right? I just took this formula up here, and without any numbers in there, I solved for x. What do I get? This is actually what we're doing here. That's the formula that we're using. So, then I come back here, I come to page 93. Are you wondering why I'm working 20 problems out of this? No. I mean, you should be kind of happy, but why am I doing it? Because I don't want to have to do it later. Later, I want to come back and say, remember that shit we did where I found a z-score and all that stuff? Then I can concentrate on the probability and then the stuff at the end of the semester instead of saying, remember the normal distributions? I want to make sure we get this down. Okay? So, on page 93, there is a 3.14. It's still the MCAT test. It says, a new version of the MCAT test, it's the same instructions I read for you, whatever that other problem was, 312, was introduced in the spring 2015 and is intended to shift the focus from what applicants know to how well they can use what they know. One result of the change is that the scale on the exam is graded has been modified, with the total score of the four sections ranging from 472 to 528. In the spring 2015, the mean was a 500 and the standard deviation was 10.6. And again, two freaking problems in the same section. Of course, it's about the same thing. They forget to mention that. But that's okay. I'm going to throw it in for you. Because if they're not normal, approximately normal, we are wasting our time. Then it says, Part A. What are the mean and the first and third quartiles of the MCAT scores, and what is the interquartile range? I'm not really worried about Part B. I'm worried about Part A. I want the median, first quartile, third quartile. Does anybody remember the formula for the interquartile range? I hope so, because you're returning in homework tonight. That's the distance between the first and the third, right? It's the length of your box in your box plot. Okay? So let me ask you this. If this guy is normal and has a mean of 500 and a standard deviation of 10.6, do we have to calculate the median? What the hell's the median here? It's symmetric. What do we know about things being symmetric? The mean and median, if it's exactly symmetric, the mean and median are equal. Oh, I don't have to calculate. The median here is, it's symmetric. The 50-50 area point's right in the middle. The mean's right in the middle. They're exactly equal. The median is equal to 500. Everybody follow that, right? It's perfectly symmetric the way we're thinking about it. The mean and median are equal to each other. And you're going, they really gave me a problem like that? Sure. No problem. So when they ask you to find the first quartile, are they telling you some kind of percentage? What do we know about the first quartile? Now, maybe this would be a good review for us. Q1. What do we know? What makes the value Q, the first quartile? What does it do? It has I'm just going to put it like that. The first quartile has 25% of the area, in this case, smaller, less than it. So then what we've got to do is this a work backwards? In other words, when they tell me to find the first quartile, and we all know that 25% of the area of the observations are smaller than that, are they giving you a percentage in a roundabout way? And the answer is, yes, they are. All right, so this is working backwards. If you like, I can come over here and say, we need to find x. That x is going to be your first quartile, but we need to find x. So how do I work backwards? I come here, and I draw you the standard normal. Remember, I'm working from the bottom of the page up. I always label so you know when you get away from me. The mean is right here. Do we expect the first quartile to be to the left or to the right of the mean? I'm asking dumb questions. We expect it to be to the left. There's some z-score here, right, that has the area being Do I have to do any of that crazy subtracting from one thing? No. The first quartile has 25% or 0.2500 of the area to the left, right? So I need to go to Table A, read the table from inside out, find the area closest to that, and then give me the z-score. So I go to Table A, and I'm looking for, I know it's going to be negative, right, because it's to the left of the mean, so I need to be up here somewhere, and I'm looking for 0.2500, and what you'll notice is I'm in this row right here. I'm in the negative, can you see my cursor? I'm in the negative 0.6 row, and I'm going to pick the one that's closest to 0.25. I'm between two of them, 0.2514 and 0.2483. Which one is closer? I don't know what one's closer in your world. My world, 0.2514 is closer, right? By a very, very little bit. So I found 0.2514. I want to know what's your row and what's your column. So you don't lose your spot. I go to that row, negative 0.6. And then my column is, what is that, 7? It's in the 07 column. So I'm going to get negative 0.6, 0.07. In other words, up here, that z-score I need is negative 0.67. Now, here's what I would like to do. I don't want to have to solve for you every time, solve for x. Can we use this guy I got circled in blue? Everybody okay with that? That's what I need, right? So I want to use x is equal to z times sigma plus mu. Do not throw away the negative sign on your z-score. That means x is equal to negative 0.67 times 10.6 plus 500. Because the minus sign is going to make you where you go less than the mean. So when you punch all this in, I don't know the value off the top of my head. I'm hoping somebody's going to help me. I was thinking it was like 20.9 or some crazy shit like that or something. Oh no, it can't be. It's 7,400 or something. I'm looking at 500. Sorry. What'd you get? So I got 492.898. Right, we'll give them all the decimal places, then we'll pick our answer from whatever's closest. Now, did I just find the first quartile? Oh, hell, that's it, right? That's your x that has 25% or nearly 25% less. In other words, my Q1 here is 492.898. Now, I don't want to get fancy with you finding the third quartile. I want to just actually do the work because the problem may just ask you to find the third quartile and not do the first one, right? So, my question is, you understand we're working backwards. First quartile has 25% to its left. Okay, so let's find Q3. What makes Q3 so special? Well, yeah, I mean, I know there's 25% greater and 75% less. I want to work with the left because the table's always to the left, right? I don't have to do any kind of subtraction or anything. So, I'm going to go to the standard normal. This time, I'm going to be over here. To get 75% to the left, to the left. And I got to convert it to proportion, move the decimal place to the left. Okay, so now we're running to the table. I'm going to give you a hint. It should be kind of symmetric with what you found before. Table A. You're not going to find exactly 0.7500, but I surely should be in the positive side of things. I'm here in this 0.6 row, and over here between the two, I got 0.7486, 0.7517. Which one's smaller? Which one's closer? 0.7486. So what row? What column? When we see our answer, I got to ask you a crazy question. I'm in the 0.6 row, and I'm in the 0.07 column. I'm in the 0.6 row, 0.07 column, 0.067. Now, I got a question for you. Just, what was my answer to 25%? Negative 0.67. This one's 0.67. Does it make sense that they're just opposite of each other? Right, you go negative 0.67, you go 0.67, and this one has 25, and this one has 75, between them has 50. Yeah. Don't be shocked that it's nice and symmetric around the center there. Do these numbers ever change when the problem changes? In other words, does this number ever change? Is that not the z-score every time you look up the third? It's not going to change. It's got nothing to do with the mean and standard deviation. Back here. Does this number ever change when you look up the first quartile? I can give you any normal distribution you want with the mean and standard deviation. That's going to be your z-score you use for the first. Nobody's expecting you to memorize that. And this is going to be the z-score you use for the third. Okay? What's my formula again? X is equal to z times sigma plus mu. Plug in what you get. I apologize the way I had that written. I definitely wrote it bad here. 0.67. Did I write it bad there? No, I wrote it correct. 0.67 times 10.6 plus 500. So you got this time 507 something. 507.102. Folks, that's your third quartile. And notice, both of those, the 4.93, whatever in the hell that number was, 4.93, 4.928998, and your 507.102, they're the same distance from the center, right? You went this way and you went this way. We had one more problem. We had one more thing to do here, right? I was supposed to find the median. No work. First, third, and the interquartile range, which is the value of the third minus the first. It's the length of the box. It's the range of values between the first and the third, the middle 50%. What was this? It was 507.102 minus 492.898. It just seemed right, and then whatever number you get. Somebody tell me, because I like to be thorough. What was it? 2. Yeah. If you cut that in half, you'd go 7.102 one way and 7.02 the other, which makes sense. It's the quartile, right? There's 25 this way and 25 this way. Now, we're going to stop there because I've done 2 of every type I could think of out of this chapter. On Thursday, we're going to talk about, actually, we're going to change parts of the book. Rob, go ahead and hand back your stuff. I'll give you guys this stuff back. You folks who are streaming, I will email yours back. What you're going to see when you get your homework back is there was 24 things I checked for. I don't know how many problems we did. And so you're going to see a number divided by 24. Now, that's still not points, right? You know, at the end of the semester, I had all the bottoms together, I had all the tops together to figure out the number of points. And so what you'll see is I wrote some things on there about, okay, you needed to do this, this, this. You'll see like 1s and minus 1s. At 7 o'clock tonight, the solutions to that homework will show up in D2L under Content Homework Solutions. Take a look at it if you missed something right before you start screaming at it. All right? Yeah, that's where we're at. And then on Thursday, we're going to change parts of the book. The first 3 chapters were together. We're going to chapter 4. Now we're going to start looking at 2 variables at a time. And actually, 4 and 5, we're going to look at 2 quantitative variables and to see if there's a relationship. So we're going to start over again with a graph. All right? When you get your stuff back, be careful going to the house, and we will see you on Thursday. Kayla? Bishop? I haven't gotten any good. I'm working on it. Abby? David? And then everybody else. I got one from everybody. We'll have to send it. I got to email them back to you.
Thank you.